I'll now briefly discuss two integrations that I have recently worked on. Let me share my screen. All right. Cool. So first, I'm going to show the Flyte Banana integration. For those who haven't heard of Banana, it's an ML inference solution that does inference on serverless GPUs. I just want to go through the process of orchestrating a fine-tuning pipeline and enabling on-demand scalable model serving with Flyte and Banana, respectively. You can either use the same pipeline or build your own ML pipeline. So the first step involves fine-tuning a BERT pipeline with Flyte. This pipeline downloads the dataset, Yelp dataset, from the Hugging Face hub, tokenizes the data, meaning applies the tokenizer to the Yelp dataset and stores the result in a directory and returns the same. And then the pipeline splits the dataset into train and evaluation subsets. It then fine-tunes a BERT model. So this task fetches a pre-trained model from the Hugging Face hub, defines a trainer, trains or fine-tunes the model on the Yelp dataset, pushes it to the Hugging Face hub, and finally returns the Hugging Face model SHA, the Flyte execution ID, and the name of the Hugging Face model repo. And then in the end, the pipeline sends the model metadata to GitHub. There are two reasons for doing this. One is to trigger the Banana deployment, since GitHub push event triggers a Banana deployment. And the other is to ensure data lineage throughout the pipeline. Now, this task stores the model metadata in a file and pushes it to a GitHub repo. And you can reuse this task for your Flyte Banana deployment as well. And then you can run the pipeline locally. This workflow includes an approval task. So here's the approval task. Now the retrained model gets deployed only if the user approves the deployment. And then to serve the model on Banana, create an account and link it to the GitHub repo that has the model metadata, because that gets updated whenever there's a retrained model. And this inference code initializes the model by fetching it from the Hugging Face hub, and then generates predictions on a GPU if there's one available. And then you can test the endpoint by spinning up a Banana server locally. Here's the code for that. And yeah, to deploy the model on Banana, you need to prepare a Docker file, and it can be identical to the one that I'm using over here. And then to run the pipeline on the Flyte backend, prepare a Docker file, register your tasks and workflows, and execute the pipeline. On clicking resume, the deployment on Banana gets triggered. Next, you can trigger the deployment on, you can test the deployment on Banana by hitting the endpoint and generating predictions. And yeah, that's about it. This video captures generating predictions with Banana. Let me just go to the Flyte console. So in here, let me just refresh this. I have triggered the workflow already. Now the workflow is waiting for the user input. So let me just resume this. And hence the deployment commences. And this pushes the model metadata to GitHub, and it also deploys the model on Banana. Let me just go to the Banana dashboard. But before that, let me just go to the GitHub repo. Yeah, I'll just open one of the older commits. So here's how the commit looks like. The SHA got updated, and the execution ID got updated as well. And this is the Banana dashboard. So the model gets deployed again, and you can hit the endpoint to generate predictions. So yeah, that's about it. Let me now open the DuckDB blog post. All right, so many of you must have already heard of DuckDB, right? So for those who haven't, DuckDB is a SQL DBMS that's designed to handle analytical workloads. It stands out for its speed and the capacity to handle sizable data sets. Now I'm going to walk you through some analytical queries I ran on a few gigabytes of NYC taxi data, all within a Flyte workflow so that you can get the gist of how you can use DuckDB within your own data and analytics workflows. And then the first step involves fetching pickup and drop-off hours over a span of 4 years from 2019 to 2022. So here's the task for that. It loops over two lists of years and months and runs DuckDB queries on the Spark-A data. So here are the definitions for the DuckDB queries. So here's this is how you need to instantiate them. Give it a name, a query or a list of queries, and the input that is to be sent to the query. In here, the input is a Parquet file, and it gets replaced over here. So this is to fetch the pickup hour, and this is to fetch the drop-off hour. And the pickup query and the drop-off query tasks are triggered simultaneously in the dynamic workflow, which results in expedited executions. Next, the coalesce DFS task. It merges the structured data sets for a group of years. And then it, so it basically uses WEX data frames because WEX can be helpful to run queries on larger data sets. And we have an existing plugin for the FlyteKit WEX plugin. You can install and use it directly. And then the pipeline renders a graph to visualize the pickups and drop-offs from 2019 to 2022 using Flyte Deck. And then it retrieves the pickup peak and off-peak hours. Here's the dynamic workflow to handle that. After I ran the workflow, this is the output I've got, the pickup, the peak and the off-peak hour for every year. And then these are the DuckDB queries I'm calling from within the peak and off-peak hours dynamic workflow. These DuckDB queries accept arrow table as inputs. So I'm sending an arrow table to this query. And if you look at this parameter, it's the same over here as well. So this retrieves the peak hour, and this query retrieves the off-peak hour from the arrow table. And then, I ran the workflow, and these are the execution DAGs I've got. Let me now quickly go to the console. I triggered the workflow already a while ago. So here's the first dynamic workflow. This is the task that generated the plot. Let me just refresh the page. All right. So here's the plot. And then this is the final dynamic workflow that retrieves the peak and off-peak hours. And here's the graph for that, like for the peak and off-peak hours. And this is the fetch trips data graph. And that's all I have. If you like a comprehensive overview of the integrations, I recommend you to read these blog posts. Any feedback or questions?
I had a quick question about the push to GitHub task. That's something that can be generalized, right?
Yeah, it can be.
So as long as you have some GitHub workflow that responds to a pull request or whatever, whatever event, we could basically use that as a little webhook thing for Flyte, right?
Yeah.
Cool.
Yeah. You can actually propose this idea, to use, to encapsulate all of this in a Flyte task, to encapsulate the GitHub thing in a Flyte task. So,
yeah, that'd be awesome to have a guide for that. I don't think it was like one little task, right? There should be like just a little bit of setup and configuration, but seems pretty simple.
Yeah, since it's a public repo, it was quite simple. I mean, you need not really configure anything.
Oh, because you can push to a public repo? Is that what it was? Samhita, or do you need secrets?
I mean, even if it's private.
Yeah, you could add secrets, right? Yeah, that'll be a good addition, I feel.
Martin?
Hey, Samhita, I'm Martin Stein. I'm with Union. I just wanted to ask you an experience question about Banana ML, about your earlier overview. What obviously is really great to have serverless, hosting for endpoints and so on. How did it feel to put this together? Were you excited? Is that an exciting platform to use? I mean, what was your personal sentiment? That's what I would want to know.
Oh, yeah. I enjoyed building the integration. Banana was great. It was quite simple to set up. And integrating Flyte with Banana was simple as well. I mean, I spent like 2 or 3 days and I got the integration up and running. So yeah, it was good.
And then as a follow-up question, for people considering obviously production environments and having endpoints, we always think about, having those really, the platforms that are out there for a while, but serverless is an interesting thing. Is that enterprise ready? I mean, just a very naive question, but I just want to ask you, what's your take? Say, hey, look, if you have a large scale deployment and you have a model that is actually mission critical, latency wise has to be good. Does that get your thumbs up too?
Yep, it is production ready. It can be used for large data sets and large models. So, yeah.
Fantastic. I'll try it. Thank you so much.
Thank you.